Welcome back. In this video, we're going to go over section 3.6, which is about graphs of functions. So as you may recall, for a relation to be a function, each x value can be associated with only one y value. In other words, there were no repeated x's. How that appears if we're looking at a graph, we can tell by using what's called the vertical line test. The vertical line test says a graph of a relation is a graph of a function if and only if no vertical line intersects the graph more than once. So easiest to see how that works with an example would to decide whether each of these is a graph of a function. Looking at the graph on the left, we want to know, is it true that no matter where you were to draw a vertical line through the graph of that relation, would it intersect only once? And it looks like no matter where you would draw that vertical line through the graph, it would cross only one time. How that is related to the idea of a function is this. If you draw a vertical line through the graph, you're essentially picking out an x value. You're saying, okay, well, right here at this particular x, how many y's are there? Let me put just one on here so it's not so cluttered. Okay, let's say right here, 2. At this particular x value, there's only one point where it crosses. And no matter where we do that drawing of a vertical line, there is only one crossing. So for each x we choose, there is only one y value. This is in contrast to how the situation looks in the next function. Here, there's a lot of places where if you choose a particular x value, there's more than one y value. So if you choose x being 1, it looks like there are 2 y values. In fact, most places, there's going to be 2 y values for each x you choose. It looks like maybe just at -1 we would be okay. But if there's even one place where you can choose an x value and there are multiple y's, then that means that it's not the graph of a function. That's how the vertical line test works. So the graph on the left is the graph of a function. The graph on the right is not a function. That's how the vertical line test works. For the next part, I wanted to do an example where we look at the graph of a function and we consider what the domain and range are. So this is an example of a function whose graph consists of 2 straight line segments. Just to make sure, if you were to pass any vertical line through the graph, it's only going to cut through the graph only one time. So it is the graph of a function. We want to look at the set of inputs and the set of outputs for this. By the way, this little E-looking symbol right here is a set symbol, and it means element of, or it indicates belonging. So this is a way of saying X is in a certain set of numbers. And here we're going to enter our answers in interval notation. So we want to look first at the set of inputs, or X values. So for this, it looks like the smallest X we have is -5, and the biggest X we have is at 3. Another way to picture where this set of inputs is if we were to smash this whole graph against the x-axis, how much would get colored black? The part that would get colored black is the interval between -5 and 3. So x is in the interval -5 to 3. That's the set of inputs. Next, we want to look at the set of outputs. So that's the set of y values. It looks like the smallest y value is 2 when x is 0. So f of 0 is 2. And the biggest y value is 5. F of -5 is 5. Again, a way that you could think of this is picture if we were to smash this whole graph against the y-axis this time, because it's outputs, how much of it would get colored black? And it looks like it's just the interval between 2 and 5. +2. Okay, that's most of this section. When you look in the assignments, you'll see that a lot of it is about graphing a particular function. For this, you can do this by plotting points. In the case of lines, you can do it by using the equations of lines in order to get the graphs done. But this is the kind of the key ideas out of this section. So finish with it. Let me know if you have any questions, and have a great day.